Oh, hello, class. I want to make a comment here. This is an exercise, the ones that you see at your left. It's an exercise from your homework number 7. Probably this exercise is, I'm not going to say that it's difficult, but it might be a little bit challenging. Okay, so that's why I want to make some comments. So we have here, I'm not going to go through the detail of what the numbers means and so on. But what we have here is a histogram, okay? So just let me detail a little bit what we have in the horizontal scale axis and the vertical axis. So in the horizontal axis, we have the outcomes of the sample that was surveyed, okay? So there was a population, residents in some place, they were surveyed, or it was measured something in that population, and they found these possible outcomes that range from 1 to 12. And what is the meaning of those numbers? The meaning of those numbers are the murder rate per every 100,000 residents. And they collect that. So they took a sample, they measured that, and they found that for one murder per 100 residents, they have a frequency of 5, and so on. Okay, so the outcomes are murder rates, and these numbers that you have here are the high of this bar, which is the frequency. For instance, 5 is the high of this bar, that is 5. It's just to help you, right? So this is the frequency. So the first thing is in this histogram, well, this is the horizontal, the vertical is the frequency. The number that is over the bar of each one of the bars in this bar graph is the height of the bar, which is the frequency. Okay, so they put it here just to remind you or to help you to read this number. Okay, so if you want to know what is the length of your sample or the length of the sample that you took in this survey, what you need to add is all the frequencies. I mean, you need to add all these numbers. Okay, so in here we have 5 plus 9, that is 14, 16, 19, 25, 34, right? Plus 10, which is 44, plus 9, which is 53. So let me write down here. So the length of the sample is 53. Okay, now remember, the histogram is a graphical representation of your distribution frequency. So for each outcome is telling to you what was the frequency of that outcome. For instance, for 9, I mean 9 murder rate per 100,000 residents, the frequency was 9. Okay, and so on. So if you want to compute the mean, well, what you need to do is to take all these outcomes and multiply that outcomes by the corresponding frequency. 1 times 5, and then you add those values, plus 3 times 3, and so on, and so on, and so on. And then you add those values, and when you have all that summation, you're going to divide by 53, and that is going to give you the mean. That's the way to compute the mean over here. That's one of the things that I want to tell you. Okay? So let me just write that a little bit. So you need to take, for instance, one of the outcomes is 1. Let me write down here. Is 1. Then you need to multiply by 5 because the frequency of this outcome is 5. Then you have another outcome that is 3. I'm not taking into account 2 because 2 is 0. 3, but how many times is going to show up 3? It's going to show up 3 times. So you need to multiply by 3. Then for the outcome 4, you need to multiply by the corresponding frequency, that is 3, and so on. And so on until you get to the last one, which is 12. I mean, a murder rate of 12, right, per 100 residents, which is 12. And what was the frequency of that one? That was 3. Then you add all this number. I'm going to say that this addition is A, and the mean is going to be this number A divided by 53. That is going to be the mean. Okay, that's what I tried to say before. No? So this is the length of the sample. This is the length of the sample that was taken. And this guy here is the mean. And what is A? A is the summation of all the outcomes multiplied by their corresponding frequencies. Okay. Now, if you want to really know what is your sample, your physical sample, you can reveal that from the histogram or the distribution frequency, because this is not your original sample. Okay, your original sample, that is a list, is the following: is all these realizations, but with the repetitions. For instance, 1 is one of the outcomes, so this is 1, 1, 1, 1, and 1. How many times? 5 times, because that's the frequency that is telling to you. Then 0, 2, no, there is no a murder rate of 2 for every 100 residents, so we don't put anything. For 3, well, is 3, 3, 3. For 4 is also 3, 3, and 3, and so on. I'm not going to make the complete list because it's too long. How many elements I'm going to have in this list? 53. But I'm going to put the last ones. So 12, well, 12 was 3 times. This list is really your original sample with all the outcomes, okay? From here, they build the distribution frequency, and with the distribution frequency, they made this histogram. Okay, but this is the original data. Okay, and in here we have 53 elements. Okay, so if they say find the median, like here, find the median, okay, so the median is what? The median is a descriptor of the central tendency that have to do with the center position. And the center position is gonna depend of if the length, which is n, is at even number or at odd number. So in this case, n is 53, is an odd number, so that position is going to be the median, and I'm going to put it here, median, is going to be equals to the outcome of my survey just in the middle of the list. What is the middle of the list? Well, that position is, I'm going to put here positioned. What is that position? Well, that position is going to be, well, the middle of the list is going to be the position 27th, right? 27. So we need to know what was the outcome in this position 27th. Of course, if you were patient and you create your complete list, well, you can identify the middle of the list and you can check what is this position. But if you didn't make it, what we can do is to count here the frequencies and to look for which value here in the outcome we get onto 27. So let's go. So this is 5 plus 9, which is 14. So up to here, up to this outcome, we have 14 positions. Then we have 14 plus 5, which is 24. 24, okay? We are not covered that position yet, okay? Okay, let's count again. So we have 5 plus 9, which is 14. 14 plus 5, oh my error, 14 plus 5, which is 19. 19 plus 6, which is 25. We haven't covered that position, but for sure, in this group, we're going to cover the position 27. So for the position 27, the outcome was 9. So the median is 9. Okay? So that's what I want to tell you, because probably this is kind of a challenge, or a little bit challenge. It's just to understand that. Now, in the next question, they say, are the median and the murder rates consistent with the shape of the distribution that you describe in A? Well, what is the shape of the distribution? Well, we can see that the distribution is skewed to the left. It's skewed to the left. It's no center. So what happens when we have a histogram that is no center, like a bell shape? That the descriptors, especially the median and the mean, are going to be different, okay? So what is going to happen is in here that I haven't made the computation of the mean, but if you made the computation of the mean, most likely that the mean is going to be influenced for these numbers that are to the left. So most likely that the mean is going to be lower than the median, okay? So, so for instance, if you compute here, it makes sense that the mean is going to be lower than the median, and in here, then you need to say that yes, it's consistent. The mean is whatever the mean is lower than the median, and as a consequence, is consistent, okay? So that's what I want to tell you. So in here, this histogram is skewed to the left. Okay, well, this is what I want to comment here in this exercise, guys. Thank you.